Welcome, math friends. We're here to talk about inverse trigonometric functions today. We have these six trigonometric functions that we use: sine, cosine, tangent, cosecant, secant, and cotangent. And we want to look at their inverse functions. Remember that two functions that are inverses actually have a domain and a range that swap. So the x and the y's switch places. And in order for you to have inverse functions, your functions need to be one-to-one. And what that means is it doesn't violate the vertical line test or the horizontal line test. So for every x, there is one y, and for every y, there is one x. So you need to look at your six trig functions in general. Your sine function has this wave that is periodic to pi. Cosine, same thing. Tangent is periodic pi, but that means that it repeats. And so you're getting multiple y values for different x values, which means that it's not one-to-one. And so we're going to need to restrict our domains in order to make these functions one-to-one and thus have an inverse. We want to look at our sine graph and make sure that we have a portion. We want to restrict our domain so that we not only don't violate the vertical line test, but we also don't violate the horizontal line test. Sine is a function. I'm good to go on the vertical line test, but if I was to take a horizontal line here, you notice that I am hitting multiple y points on that horizontal line. That's not good. So I need to make a restriction so that I only have one individual y for every x. So let's start down at the bottom over here for at negative pi over 2, and let's go up the sine graph. All unique y values up until the top. And then once I reach that top maximum point and I want to start to come back down, I would be repeating a y, which I don't want to do. So this is where I'm going to restrict my domain. I'm going to go from negative pi over 2 to positive pi over 2 for my domain using interval notation and brackets because I can't include those two values. And then my range is going to be from -1 to 1. Keep in mind that with our inverse function, if we use the inverse sign, we're going to reflect our graph over that y equals x line, but also our domain and our range is going to switch. So we're going to come back to that. Let's look at cosine. For cosine, let's start at the top and drop down. As soon as we were to come back up, we would be taking on another y value that we've already used. So this is going to be where I restrict my domain. I'm going to go from 0 to pi. And then my range is also going to go from -1 to 1. Let's look at tangent. Tangent's a little bit different. Tangent takes on all y values. It goes from -infinity all the way up to +infinity. So my range here is going to be from -infinity to +infinity using parentheses because remember, infinity is a number getting larger and larger without bound. It's not an actual value. But the domain I'm going to restrict, I'm going to go from down low all the way up. And tangent has those vertical asymptotes and it repeats every pi. So that asymptote repeats at negative pi over 2, pi over 2, 3 pi over 2, and so on. So I'm going to restrict the domain to where those asymptotes are. But because I'm approaching infinity and -infinity, but I'm not actually taking on that value, and I have asymptotes, my domain is going to be from negative pi over 2 to pi over 2, but I'm not going to include those values. Okay, let's get into cosecant and secant, and then cotangent as well. Looking at cosecant, which is the reciprocal of sine, I want to make sure I don't repeat any values. And what I'm looking for here is if I was to start at the top of this parabola and drop down and then come from +infinity down to here, as soon as I was to go back up the other side of what looks like a parabola, I would be taking on another y value. Same thing with down on the left. So what I'm going to be doing is I'm going to be going from negative pi over 2 to pi over 2 here. However, notice as I approach 0 on the left-hand side in quadrants 2 and 3, I'm getting to negative infinity, but I'm not going to take on that value. And then in quadrants 1 and 4, I'm getting to positive infinity, but I'm not going to take on that value. So I'm never actually going to take on the value of 0 for x. And if you think about the reciprocal of sine, if you're using 0 and you do 1 over 0, that's undefined. And so 0 at this point does not take on a specific value, which means I need to split my domain and go from negative pi over 2 to 0, not including, in union with 0 up to pi over 2, which I do include. And then the range is going to go from negative infinity up to, notice that it doesn't take on all values. There is a gap here from -1 up to +1. So I also need to do a union there as well. I'm going to go from negative infinity to -1. I can take on that value in union with 1 to positive infinity. Let's look at secant now, which is the reciprocal of cosine. Make this a little bit smaller. Secant also has a gap in my range, and let's take on some values where I don't have any repeating y's. Remember that cosine started from 0 to pi. We're going to do the same thing here. Starting at 0, I go up all the way to infinity, and then I'm going to go to pi here, down. And there looks to be an asymptote right here at pi over 2. Think about what cosine is at pi over 2. Cosine is 0 at pi over 2, and you can't divide by 0. So my domain is going to be from 0 union up to pi, but I need to split at that pi over 2. That means I'm going to go from 0, which I can include, to pi over 2, which I cannot include because that's an asymptote, in union with pi over 2, which I cannot include, up to pi, which I can include. And then in my range, notice that I have that gap from -1 to 1, which means I'm going to go from negative infinity to -1 in union with 1 to positive infinity. And I do have values of 1 and -1, so I can include those values. Lastly, let's look at the cotangent function. Cotangent looks like tangent, but it's the reciprocal because cotangent is the reciprocal of tangent. And so instead of going up and to the right for each of my curves, I'm going down as I go to the right. Let's restrict our cotangent from 0 to pi. I'm going all the way up to positive infinity and down to negative infinity for my range, so I can take on all values there from my range. My domain is not going to take on 0 or pi, but it's going to approach them. So my domain is going to be 0 to pi, not inclusive. Okay. Now let's look at our inverse trig functions. We're going to switch the domains and the ranges for each of the reciprocal functions. So inverse sine of sine, domains and range changes. Inverse cosine, inverse tangent, we're going to take the domain and range that we've determined and we're going to swap them. Off to the right, I've written the domain and range for sine. The domain of inverse sine is then going to be -1 to 1. And the range for inverse sine is going to be from negative pi over 2 to pi over 2, inclusive. My graph that was curving sideways is now going to curve up and down. So my graph for the inverse sine is going to look like this. Okay. The domain of cosine was from 0 to pi. The range was from -1 to 1, which means that our domain and range are going to switch. The domain for the inverse is then going to be from -1 to 1, and the range is going to be from 0 to pi. You see how the curve went on the regular function and then the inverse. Looking at tangent, the range of regular tangent is from negative infinity to infinity, which means my domain for the inverse is negative infinity to infinity, which means that the graph is going to go on all the way to negative infinity in x and positive infinity as well. So it's going to be horizontally extending. And then the range goes from negative pi over 2 to pi over 2, but doesn't approach it. So those are actually going to be asymptotes for this inverse tangent. And the graph is going to look like this. A little bit more of a curve to it, but you get the idea. Now you'll see that we have in each of these, if you've looked at the notation, you've got sine to the negative 1x or arc sine. Arc in front of the trigonometric function is inverse. It's another way to say inverse. And this is not sine to the negative 1 power. Remember, that is the inverse notation. Let's look at the cosecant now. These domains and ranges are a little bit trickier because remember, there's certain values that are not taken on and we have asymptotes that need to be represented. So our domain is now going to be from negative infinity to negative 1 in union with 1 to infinity. And then our range is going to go from negative pi over 2 up to 0, but not included, and then from 0 to pi over 2. Let's look at that graph. So the domain has a gap from negative 1 to 1. Secant's going to look similar because cosine looks similar to sine. There was an asymptote at pi over 2, and the values from negative 1 to 1 on the range were restricted, which means that's going to happen in our domain. Our domain is then going to be from negative infinity to negative 1 in union with 1 to positive infinity, and our domain is going to go from 0 to pi over 2, have that asymptote up to pi. The vertical asymptote at pi over 2 is now a horizontal asymptote. And we have that gap from negative 1 to 1. And we go from 0 up to pi with that split. And finally, we have cotangent. The range now becomes the domain, and the domain becomes the range. And instead of the graph going up, it's going to go sideways. That vertical asymptote at pi is now a horizontal asymptote at pi, and the graph goes from negative infinity to infinity on the domain, and it drops down at pi over 2 and crosses over. Those are the 6 inverse trigonometric functions. I hope that seeing where the domain existed in order to make it a one-to-one function was helpful. Seeing how the domains and the range switched and what their graphs look like was beneficial. Thank you so much for watching. Have a great day.